talk about this very briefly. We can talk about all of these selection rules using term symbols. And I'm not going to spend as much time lecturing on this because here I've got it in this document. But here are our term symbols given by the same rules we had before, right? But now we can recognize these term symbols, or excuse me, we can recognize these selection rules from their term symbols, okay? And so this notation right here, but J, so what this means is cannot go from J equals 0 to J equals 0, but that's only for very light atoms, for the less massive atoms. And what we're also going to start to see as we go down the rabbit hole even further, there are times in which these selection rules can absolutely not be broken. But of course, because chemistry is the science of exceptions, there are also definitely times when these rules can be broken. So that's why I'm not going to spend as much time with this, because again, this gets into the crazy, like all of those rules like you learned in inorganic chemistry for the exceptions. I don't want to spend as much time with the exceptions. I really just want to kind of spend time going through the main observations. Okay, so this here is the helium spectrum. So this is for helium. And of course, everything down here is 1s0, ground state helium. And so you can see that helium, if you recall, we started this discussion noting that with helium 1s2, when we go to promote it to its first excited state, that's a 1s1, 2s1, which can create a series of triplets or a series of singlets. And here we can see that. So here is our series of triplet states, and here is our series of singlet states. And so you can see that the L value can be 0 or plus or minus 1, but not plus or minus 2. So I can't go from a D term to an S term, but I can go from a D term to a P term, or an S term to a P term, or I can also go from a, let's see here. Here we're not seeing any P to S, or excuse me, P to P. No, there is one right there. I just missed it. There is a P to P term right there. Okay. But what's important to note it is there's no singlet to triplet conversions. That's forbidden. And so that's given by, where is it? Right here. Delta S has to be 0. So that is a forbidden transition to go from a triplet to a singlet. And that is never, hardly ever observed in atoms, but oftentimes in molecules, we can get conversions from singlets to triplets. And I'm going to talk about more of that exception with molecules as opposed to atoms, because very rarely do atoms, especially the lighter atoms, very rarely do they break these rules. Okay? So let's see. I'm just going to see if there's anything else to go through. So this is a really handy guide to go through. I think they also show us here. Yes, so they kind of described what I was going through. Perihelium, as it turns out, because it's you get different magnetic states of helium because of the electron configuration. So perihelium corresponds to the singlet, orthohelium corresponds to the triplet. Let's see what else we have here. I think, yes. So this is giving us a diagram for hydrogen. Okay, and so this is now all the levels. It's showing you the splitting of all the levels for hydrogen based on the fact that hydrogen is a doublet state, right? A one electron system. So there's going to be tons of splitting for hydrogen being a doublet state. And all of these arrows give you the allowed rules, okay? So